Good day, guys. I hope you're all doing so well. So, on today's lesson, we're going to deal with theorem number 6 of circle geometry that talks about tangent and radius that are perpendicular to one another. So, I hope you're going to enjoy the lesson today. Let's just start without wasting any time. So, now, theorem 6a, we have our converse, hence we have 6a, and we're going to have 6b after this one. So, this theorem 6a, it says that a tangent to a circle is perpendicular to the radius at its point of contact. I'll just explain what is a tangent. A tangent it is a line that touches the circle at one point outside, obviously. So a tangent is a line that touches the circle at one point outside the circle, outside of it. So in this case, this line TAN, it is our tangent because it touches the circle at point A. Now this tangent is perpendicular to the radius. What is a radius? Radius is a line that touches, that comes from the center of the circle to the circumference, half of the diameter. The point that starts from the circle to the circumference. This is our radius. So this tangent is perpendicular to the radius at its point of contact. Basically, where they meet, these two lines, our radius and our tangent, they are perpendicular at this point A, point of contact. Basically, we have 90-degree angle here on both sides. I hope you understand the theorem, what it says, guys. I hope you clearly, properly understand this theorem. At this point of contact, they form a 90-degree angle. So, if line TAN is a tangent, therefore OA is perpendicular to TA. Why? The reason you can use for this theorem, it says that the reason for this theorem is tangent perpendicular to radius, if and only if we have a radius that is perpendicular to the tangent. Guys, I hope you understand this theorem so well. So if you have questions, you can just post them without any hesitation. So this is the reason you can use for this theorem 6a is going forward, if and only if we have this kind of situation without the inclusion of the perpendicular symbol in the diagram, then you can just conclude by saying, if you have a radius and a tangent, then this point, or this point A, it is perpendicular, or it is equal to 90-degree angle. If and only if this is the case in the other example going forward. Let's go to the converse, or the exact opposite of theorem 6a. Here's our converse, guys. Theorem 6a, we talked about if TAN is a tangent, therefore OA is perpendicular to TN. Reason is tangent radius. Tangent perpendicular to radius. 6b, it talks about the exact opposite, basically. I will explain what is the opposite, what is the difference between 6a and 6b. Let's explain the theorem. A line drawn perpendicularly. Now they tell you there's a line drawn perpendicularly to a radius. I have already explained what is a radius. You know this. This is our radius. At the point of, which means a line drawn perpendicular to a radius at the point where the radius meets the circle is a tangent to the circle, meaning that there is a particular line that is perpendicular to the radius at point of contact. That line is a tangent. Which line? Our radius meets this line at point N, and there's a and and our radius is perpendicular to this imaginary line. You don't know this line, but since we know, okay, these two lines, our radius and this line, they touch at point N and they form a 90-degree angle. That means this line here is our tangent. Therefore, you can conclude by saying it's a tangent according to the statement, guys. So now, the reason you can use for this theorem, if and only if you are given a 90-degree angle and you have a radius and a line, the reason you can use ukuthi, therefore LNE is a tangent if and only if we have a 90-degree angle and our radius. If they ask you to prove ukuthi LNE is a tangent, you need to prove ukuthi angle N is equal to 90 degrees in the near future. And if that's the case, then you're gonna say why we have a line perpendicular to radius. This reason you're gonna use it if and only if they didn't tell you what LNE is a tangent, and then if and only if angle N is 90 degrees and you have a radius and you have a line N and LNE. If they say, well, you must prove something, you start by saying okay, LNE is a tangent because of what? There's a line perpendicular to radius. This line LNE is a line, is perpendicular to radius. Therefore, this will make sure okay, LNE is a tangent. Then you'll conclude by saying LNE is a tangent by so saying that. I hope guys you clearly understand this theorem. Let us go to theorem 7. Theorem number 7 is so simple now. They ask it sometimes, but not at most of the time, guys. Yes. Theorem number 7. I will just try to explain it properly. Yeah, it's so simple. It requires your attention. It requires your attention and focus. So theorem 7 it says that let me just take another pen, another color. Yes, guys. Theorem number 7. It says that two tangents. What is a tangent? Line that touches the circle at one point outside of it. In this case, which lines are tangents? These two lines. Line TB is a tangent because it touches the circle at point B outside of it. And TA is a tangent in this case. Line TA is our tangent, obviously. Okay, guys. Then these two tangents drawn from the same point. Which point? Point T. Outside the circle are equal in length. Meaning they're telling you what these two tangents that are drawn from the same point are equal in length. Basically, these two lines are equal in length. They are telling you that. So basically, when you need to prove indeed TB is equal to TA. You need to prove that, guys. Basically, I hope you understand what is happening here. Yeah. So you need to prove indeed TB is equal to TA. Yeah. That's what you need to prove right now. So let us go to the givens. Obviously, proving it. So you need to prove they're equal in length. Yeah. So given what is it that is given in the diagram? We're given that circle center O and we're given tangents, obviously from the statement. Tangents TA and TB. Okay, guys. Then we are required to prove that TA is equal to TB. Then construction. In the examination, they will just give you what I'm trying to write. They will give you a given. They will write what you have got to prove this and that. Then you're gonna create your own constructions by the way. So they will just give you these two elements, and when you just construct, it's a mark by the way. To construct it's a mark. Is regardless of any type of construction, but as long as you construct on a diagram, it's a mark. By the way, if you ever prove any theorem, you ought to, at most of the time, you ought to construct to basically form a theorem or to form a reasoning basically. So in this case, what are you going to construct here? You have a center, by the way, center O. So you're basically must construct our radii OA and radii OB. Yes. Let us construct, by the way, guys. Yes. Freehand. I'm just doing so by freehand, guys. Yes. This is my construction. It's a freehand, guys. So please don't judge it. Then we have constructed OA and OB. We know you can see that the center here, there's a line that can construct TO, obviously. T is gonna join O, yes, to form two triangles. I hope you see them, guys. Yes, guys, this is our construction. We just try to make bold drawings now, so that they can properly see this construction clearly. Now I'm gonna write go to okay, radii OA and OB together with joined by TO, basically at point O. Now let us prove. Guys, what do you prove basically here? You need to prove that their sides are equal. So when you talk about sides, you are really trying to implicate the congruency. So you're gonna prove congruency here basically because there are sides involved. So how do you prove our congruency? So remember, congruency is all about side, angle, side, those kind of arrangements. Yes. So now let us just try to form two triangles. So I can see that this triangle OBT and triangle OAT. Yes, let me just try to make this triangle to be bold. We have triangle TOB and triangle TOA. And we have our radii. So guys, lines that are equal, those ones, lines that are equal or sides that are equal and angles are those ones with the same color. X is equal to whatever that has the same color, they're equal. Let us check what do you have. Remember that theorem 6a talks about radii and tangents. So we have our tangent TB and touches at point B, and we have a radius OB. Basically, they form a 90-degree angle. Reason tangent perpendicular to radius. Remember that reason. Even also for this one, radius perpendicular to radius, tangent perpendicular to radius. Remember that theorem 6a. Don't forget that. Now, guys, after you have arrived to this point, now everything is simple and I can just prove without matata. Yes, let us prove again. Let us prove from the triangle in triangle in triangle TAO and triangle TBO. What is happening? From these two triangles, you can see that A is equal to B. That's not, we are not allowed to argue with that because you can see from the diagram A is equal to B. Angle A, number one, angle A, first angle B, each equal to 90 degrees. Reason tangent perpendicular to radius. Number two, from the diagram, you can see that TO is common on both two triangles. TO is found in triangle TBO, and triangle TAO. TO is common. TO is equal to TO, reason common. Number 3, then the last one, number 3. We cannot say what TB is equal to TA. We're trying to prove what indeed TB is equal to TA. So you cannot involve TB and TA in your proving in congruence right now. You need to prove what they are equal, these two sides. Hence, now guys, remember you have Radi. Radi are equal in length. Remember from theorem number 1. Go back to theorem number 1 if you don't understand why do I say OP is equal to OA. I've already explained that in theorem number 1 because of Radi. OA is equal to OB. Reason Radi. I hope you understand where it comes from. Therefore, triangle. Remember, you're gonna form your triangles from what you have proven. Remember, guys. I hope you understand. So, from this kind of arrangement, we're gonna say put a triangle OAT is congruent to triangle OBT. Reason from this right angle here. TO is our hypotenuse side. TO, remember, TO is our longest side on both two triangles. So it's our hypotenuse. And we have our side Radi. So why do I say OAT? Remember, you need to put your writing in order. Writing of or naming of these two triangles in order from what you've proven. Maybe because of your lining should be improper or should be in order. You will see it properly in similarity in creature of yes, guys. So when I say in order, I mean that placement of these letters on both two triangles should be in order. Basically, if we find, perhaps let me just prove something. A is on the second, B is on the second part. So then we have TO. TO on the first triangle is like this. TO again is like this. So there's some kind of good arrangement. Then OA, here's our OA, here's our OB. They're arranged in order. You can, as long as they're in order, you can put it in anyway, but as long as they're in order from what you've written here, then you're good to go, guys. Yes. Basically, if A is equal to B, then A should be on the second spot, B should be on the second spot, or A could be on the first spot, B should be on the first spot. It's not a problem. TO, TO is like this, TO is like this. OA, O is like this, and OB is like that. So they're in order, basically, guys. I hope you understand what I'm talking about, but you understand it properly when you read it. Similarity and proportionality in title. Yes. Then therefore, TA is equal to TB. Reason from congruency. From congruency. TA, TB. Where's TA and TB on this? Here's my TA. TA, TB. They're in order also, guys. You can see that from that. So you can prove from this congruency good indeed there's TA, there's TB, they're equal. Basically, if they're arranged like this in this congruency, that means they're equal. You can conclude from this go to they're equal. Basically, I hope you understand what I'm talking about. If you don't understand, just click on the comment section for clarity seeking questions, or on my email 2200319219 small letter CUT@gmail.com, or on my WhatsApp 082 or you can just on Facebook with Tutor Music Culture. Yes, guys. I hope you're gonna enjoy your day, and we are trying to build a momentum for final examination. So just stay with me, because we're gonna build one another in trying to combat the final examination together with trial examination that is coming about in September. So let us work together. Thank you very much.